Welcome to USDA Natural Resources Conservation Service. My name is Tiffany Carter, and I'm a research soil scientist located in Lincoln, Nebraska. Join us to learn more about why healthy soils are so important. We'll meet a new friend, Sammy Soil, and go on an exciting conservation adventure. We'll learn about some exciting careers and what makes working at NRCS so much fun. First, I have a question for you. Where does the food on your plate come from?
What we do is take soil, plants, water, and sunlight, and we make groceries, the wise farmer told me with a twinkle in his eye. That made me laugh. But when food comes from here or here, and when food looks like this, and when 20% of our meals are eaten like this, the old farmer's tale of where our groceries come from seems, well, it feels simplistic and plausible. Surely our food comes from here, right? But people who live closer to the land, they know what happens. No soil, no food. When the tough times came, our grandparents knew. The gardens, the fields, the soil. This is where our pantries were stocked. Times have changed, and we've changed, but our food still comes from the same places. Here, 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 and here. It all starts with the soil.
So now we realize that our food, and in fact our lives, are dependent on soil. Let's have a closer look.
The first thing they showed me was how the soil was formed. This happens when weather and living plants and animals break down loose rock called parent material. Parent material is typically weathered bedrock that over time becomes the main mineral component of the soil.
It looks like rock when you dig it out, but as you can see, it's very friable, massive structure, breaks easily.
Dennis took me to a road cut to show me that over time, soil is formed in layers called horizons. These horizons tell us about their history, and they can also give us clues about their future.
This is the A horizon, or the surface layer. Look at all those roots in there. That's wonderful. The dark color is caused by the organic matter in there. And here we have what's called an E horizon, capital E. Fairly light in color, more sandy in texture, and down below it is our B horizon that contains much more clay, and you can see is much more red down here too.
Each soil horizon has unique properties like depth, color, or clay content. When these horizons are layered on top of each other over time, they form soil profiles, which can be identified by name. They are often named for the place they were first identified, like Norfolk or Durham. When it comes to looking below the soil surface, nothing is as effective as a good old-fashioned soil auger. You'll never find these guys in the field without one. I guarantee it. Now I began to see how soil profiles can tell their story, layer by layer.
This is a soil profile put into a long tray so we can look at it a little easier than it's pulling it out with the auger. In this hand here, you'll see this is the A horizon. You'll see it's much darker because it contains organic matter in here. This is the A horizon, or the surface layer. This is 8 or 10 inches below the surface. And see how red this is? All salts contain iron. And we know if we put a piece of iron outside for 2 weeks, it turns rusty. This is rusty soil.
Rusty soil, how about that? So each color has a different meaning. Bright reds and yellows mean that a soil is well drained. There's more oxygen in the soil to oxidize or rust the iron in the soils. Gray colors, on the other hand, mean the soil is waterlogged for most of the year because there is less oxygen to get at the iron. A dark brown color means more organic matter, which is mostly in the A horizon or topsoil. We can use the Munsell color book to classify the exact color of the soil.
We take the soil ped and put it behind the book and find the color shift that it most resembles. I want to say it's that color there. 2.5 YR 48.
2.5 YR 48, by the way, is a more precise way of saying red. Dennis also pointed out to me that soil depth is another way to identify soils.
This is the Cecil series because the clay content extends below a 30-inch depth. If this clay content decreased above a 30-inch depth, they're called the Packlet series.
Now we know more about soils. I have another question for you. How do we know if our soil is healthy or not?
I have a question to ask you. Is your soil healthy, functioning, and stable? One of the best visual diagnostic tools that I know of is the soil stability test. Here are two soils, exactly the same soil type. This soil has been tilled for 30 years. This soil has not been tilled for 40 years. It is covered with diverse plants year-round. Watch what happens when we drop the soil in the water. Notice how the conventional till soil is falling apart. The biotic glues in the organic matter are burned up by tillage. The soil pores have collapsed. Notice the no-till soil. The pore spaces are still intact. Do this test for yourself. I guarantee if you dig a little, you'll learn a lot.
Now we know what a healthy soil looks like. And now I would like for you to meet a special friend to help us understand conservation of our natural resources. Let's meet Sammy Soil. Hello, Sammy. Maybe Sammy can help us learn more about soil conservation.
Hi, my name is Sammy Soil. I am a tiny piece of soil. There are billions of others like me in all shapes and sizes. You step on us every day. I live on Farmer Brown's farm. Farmer Brown is a good farmer. I am happy to live on a conservation farm. Come along, my wildlife friends, and help me plant these baby trees so you can have homes, food, and clean air. I am going to visit my uncle who lives on Farmer Smith's farm. Farmer Smith is not a good conservation farmer. He causes big gullies to begin on his farm. He cuts down trees. He plows up and down hills. Oh, it's starting to rain. I must run for cover. There is no cover on Farmer Smith's farm. The grass is too short. I cannot hide from the rain. Look, my other soil friends are washing down the river. The river is choking from the sediment they cause. Where am I? I must have been carried away by a big gully on Farmer Smith's farm. This water is running very fast, and I am being carried very far away. At last, the river has stopped. I am afraid. Will I ever get back home? Oh my, I am at the beach. A little boy is putting me into his pail. His name is Johnny. He is taking me to his grandfather's. We have traveled a long way. I wonder where Johnny's grandfather lives. We're here. Johnny's grandfather is Farmer Brown. I am so happy. Look, Farmer Smith has changed his farm. He has become a conservation farmer. Hooray! I'll never be carried so far away from home again. He has made a grassed waterway where the big gully was. He plows around the hill. He planted trees on steep hills. Look, the trees we planted are all grown up. There are lots of things we can make from trees. The trees help keep my soil friends from clogging the river. Look how clear it is. Now all my friends and I can do what we're supposed to do. We can help to grow trees and plants. And best of all, we can help grow food that makes you grow.
I hope you enjoyed the adventure with Sammy Soil. You can scan the QR code here to download this free coloring book. Have fun. And now I'm happy to turn it over to my colleagues, Zach Warning and Sharon Perrone.
Thanks, Tiffany. My name is Zach Warning. I'm a soil scientist located in Belmont, New York.
And my name is Sharon Perrone, and I'm a biological scientist located in Washington, D.C. Next, let's look at some exciting careers at NRCS.
We have so many great jobs at NRCS that are challenging and exciting. Let's take a closer look at a few of the many careers you could have at NRCS. USDA employs many engineers with specialized skills in erosion control, water management, structural design, construction, hydraulics, soil mechanics, and environmental protection. We also employ those with general engineering skills. Your job assignments may include restoring streams, controlling erosion, developing water systems for livestock, improving and conserving irrigation water, or restoring wetlands. As an engineer, you will help solve a host of natural resource problems and may also become involved in helping communities recover from natural disasters.
NRCS rangeland management specialists plan grazing systems that improve forage quality and other grazing land functions. You'll suggest ways to use grazing animals to improve and sustain natural resources. You'll offer advice on water management, invasive species control, and sustainable forage production. Whether landowners want to use their lands to support livestock, wildlife, recreation, or a combination of these, you'll tailor conservation plans to help landowners meet their goals.
As a soil conservationist, most of your time is spent in the field, working with farmers, ranchers, foresters, and other land users. You'll offer conservation planning and technical help to everyone from family farmers to local government officials. You'll suggest ways to help them conserve the soil, improve water quality, manage nutrients, restore wetlands, and protect and improve wildlife habitat. You'll make presentations and demonstrate conservation to clubs and organizations and provide outreach for agency programs. You'll assist in setting local conservation priorities and then help carry them out. And you'll be able to see the results of your work on the land.
Soil conservation technicians work directly with farmers, ranchers, and foresters. You'll advise landowners about applying soil and water conservation practices. You'll survey and design conservation practices, oversee their installation, and ensure they meet our quality standards. Your work is key to agency success because your one-on-one time with producers results in on-the-ground practices that directly improve, conserve, or restore our natural resources.
As a soil scientist, you'll map and classify soils. You'll educate our employees, partners, and customers about the principles of soil health management. You'll use digital and satellite imagery to map soils and write descriptions. You'll sample soils and evaluate their quality, and work with information on watersheds, water quality, and changes in land use patterns. Your work will include scientific work in the investigation of soils, their management, and their adaptation for alternative uses. Such work requires knowledge of chemical, physical, mineralogical, and biological properties and processes of the soils and their relations to climate, physiographic, and biological influences.
Before we go, I want to let you know that at NRCS we deliver conservation solutions so agricultural producers can protect natural resources and feed a growing world. Our vision is a world of clean and abundant water, healthy soils, resilient landscapes, and thriving agricultural communities through voluntary conservation. Thanks for watching. Hope to see you soon.